Greetings. I'm Danielle Gagne, editorial analyst for Commercial UAV News, and today I'm joined by Philippe Simard, president at SimActive, to talk about current trends in mapping. Welcome. It's an honor to have you here today.
Yes, thanks, Danielle, for the opportunity to be discussing with you today.
So before we get started, can you tell me a little bit about your experience in the mapping space?
Yes, so I co-founded SimActive 18 years ago. So we've been in the field for quite a lot of time, and so we've had the opportunity to see the industry evolve. And so we're a software developer for processing data and creating map products. So that's what we've been doing. Yeah.
Fantastic. Over the past several years, there's been an increasing interest in mapping technology and what it can do for the space. Why do you think mapping is becoming more popular?
Well, I think that if you go back early 2000s or even the 80s or the 90s, the mapping that was done was through aircraft. So you would put a camera on a plane and take imagery, or through satellites. The game changer in the last few years has been drones, obviously, and one great application with drones is that you can mount a small camera on them and collect data very easily. The cost of drones is being so low; it's quite, or at least low compared to an airplane. Means that more and more people can use it, and it's made mapping really popular. So I like to say that it's been democratizing the mapping.
It's a really great way to put it. And which sensors are mounted on these drone platforms that are really making mapping popular?
Yeah, well, again, to make a little bit of history on sensors that have been used for mapping, I was talking about airplanes. Uh, in the 80s, 90s, these were huge cameras with films, traditional films. So they would actually take back these films in the lab and scan them and make them digital. What happened in the early 2000s is that digital cameras came on board, medium, large format, and when drones came into the picture, uh, uh, the sensors that were used on them were really these standard photo cameras that everybody has around to take pictures of anything. So these are definitely still used. Well, there's been some more industrial kind of higher end cameras. There's been huge progress on multispectral sensors, which basically collect data at different wavelengths. LiDAR now can be mounted on drones, so they collect 3D information about the world. And also there's always some sort of GPS that's on board the drone to collect positional information with the imagery. And so you can see RTKs or PPKs, which are basically higher accuracy devices to measure your location. So these are typically the kinds of sensors that are mounted on drones. Sometimes a combination of them.
And what kind of data products are being used to process this data?
Yeah, so basically what drone users will do for mapping is they will go out there, they will fly the area in some sort of a grid pattern to make sure that it's well covered. There will be overlap between successive pictures to derive 3D information as to mimic your two eyes. Stereo information. So the main products that are derived during processing of these images are as elevation models. So they can be surface models or terrain models. DSMs or DTMs are the words that you often hear, I'm sure. Orthomosaic. So basically, you're going to take all these pictures, you're going to stitch them and make them into an accurate map product. You can also generate point clouds with colorization information, which you can use to rotate in 3D and look at different objects. And you can also derive 3D models, which are really gaming, if you like, style, where you have textures everywhere, 3D textured objects. So there's a wide range of mapping products, but these are the main ones.
Sounds like you can do quite a bit with that. What industries benefit from the resulting data?
Yeah, well, typically it was, I think people would refer in the mapping industry to surveying. So they were used to survey areas. So drones have been helping to replace, traditional total stations that you still see. Drones allow to do that in a more quick and efficient way. You can cover more ground more rapidly with more information. But being so readily available, there's been quite a few industries that are now using drones themselves, as opposed to going to a firm that would fly the drone or the aircraft to collect imagery. So they range from construction companies, which want to monitor their construction sites from one week to another, see what's changed over time. In agriculture, they'll use, I was talking about multispectral sensors a couple of minutes ago, but basically they'll use these to see problems, to monitor problems with their crop. So basically, if there are insects that are eating the plants, they'll be able to quickly see which regions of their fields are affected. Mining, it's for normally they will use drones every other day, for example, 2-3 times a week, to monitor the amount of the volume of material that's being removed from a mining site. There's forestry, where you'll monitor, the forest cuts, trees, and such. And another example is emergency response. So say there's a hurricane, and responders come in for a few days. The first thing they will do is launch these drones, take some data, produce some maps, and then they can coordinate better the efforts in helping the people there. So that it's I'd say unlimited number of applications.
Sounds like it's only limited by our creativity and how we can utilize this data. So how does your Correlator 3D software fit into this market?
Yeah. So basically, I talked about the history of sensors, but the software, we originally designed it 18 years ago to process large format frames. So basically, the idea would be to process the images to turn them into DSM, DTM, orthomosaics. Throughout the years, we've adapted the software to support drones more recently. And so you can use our software to post-process your imagery. So once you come back from the field, or even if you're in the field with a laptop, you can put your imagery on the laptop, crunch there on the site, and get within minutes your different mapping products. The big technology advantages, again, because of our history with large format frames, which are now 300, 400 megapixels cameras, if you can compare them with the typical 20 megapixel, which is 20 times smaller, our software is super fast. It can ingest very large projects. We've had clients crunching over 100,000 frame in one single batch on one single standard PC. So it's all about fast turnarounds, where the client can produce the map products he wants in a very short period of time. Again, I talk a lot about our history, but these people flying aircrafts with large format cameras, they have always been looking at accuracy. This is probably their first and foremost criteria for judging of a map product. So Our software comes with all these tools to control, edit, and make sure that the product have a consistent accuracy throughout a given project.
Fantastic. Yes, it really does come down to that accuracy and the speed in which you can maintain that accuracy and create a good data product. So what are your thoughts about the future? What does it look like for mapping?
Well, again, we've had an exponentially growing number of users, and we see that not just us but across the industry, because you can purchase easily these drones, and that even software like ours have made it easy. We see more and more frequent surveys. In some of the industries I've cited, they would wait, to do one survey a year, whereas now they can do one survey a week or even one survey a day. The resolutions and accuracy of the data, they keep going higher. We have clients who do project at sub-centimeter accuracy and resolution in terms of the pixel size of the ground. So you can see really small features from the pictures. They will do large-scale projects, so fly pipelines or power lines with multiple drones in the same morning or in the same day, and they'll be able to crunch all that data overnight and have these mapping projects. So we see really larger and larger scale projects being done. And again, it boils down to if everybody can use it more easily, then mapping is becoming a norm. I still remember back in the days where we created the company in 2003, and it was this big fancy word, photogrammetry. There was one annual conference in each one of the market, which was being held by academics, and today, and your shows are an example of that. You've got these big shows with thousands of people showing up, and it really is for everybody. Yeah.
It comes back down to the democratization of mapping that you brought up early on in this interview.
Correct.
Thank you so much for joining me today.
Yeah, thank you, Danielle. A pleasure again.